Today we're going to start by taking a look at inscribed angles. Now, like the name indicates, these are angles that are inside a circle. And so you see an example here where we have an angle, and when it's inscribed, it means that the vertex, that corner, is on the side of the circle. So when we look at this one, for example, you see that here is our vertex. It's on the edge of the circle, and it also has this arc on the other end of the angle that is also part of the circle. And so the equation that we use that's going to be really important when dealing with any of these inscribed angles is right here, saying that the measure of angle A, this angle, is 1/2 of this arc measure. Make sure that you have this equation written down. We're going to take a look at several examples with this. You'll remember that if it has its vertex at the center, it's the same as that arc measure. Here in inscribed angles, the arc measure is the angle measure is 1/2 of that arc measure. So let's take a look at some things. Now, when you see inscribed angles, there's really 3 different situations that you may see. You may see that that angle goes right through the center. You may see that that angle has the center inside it. And you may also see that you have an angle where the center is kind of outside of our angle. All 3 of these are still called inscribed angles. They still all fit that equation where the angle measure is 1/2 of the arc measure. So here's a problem. We see here that DG, this arc, is equal to 45.6. Now remember, we said that the angle measure is 1/2 of our arc measure. So if we go up and look at this angle right here, this angle is going to be 1/2 of that 45.6. So it's going to be 22.8. And I want you to notice that if we find this angle measure, it has the same arc over on the other side. It also fits that equation where it's going to be 1/2 of that arc measure. So it's also going to be 22.8. If we look at an example like this one says that RT, here's our RT. Remember, we know that it's the arc RT because it has that curved line going over the top. RT is a semicircle. So what is the angle RST? Well, if it's a semicircle, it means it goes halfway around the circle. So it's going to have 180 degrees in it. And if that has 180 degrees, and we know that this has to have half, it's going to have 90 degrees. So the next one says, we know that arc ABC, get my highlighter back. I know that arc ABC is 184 degrees. And I know another arc, I'm going to mark it in another color so we keep it straight. We also know that BC all the way around to D, that this arc is 242. What are the measures of the angles of the quadrilateral? Well, let's start with what we can figure out here. So the first one, if we know that that ABC is 184, it means that this angle has to be half of that, which would be 92. And likewise, if we know that BCD is 242. This one that's across from it is going to be half of that, so it's going to be 121. Now, we have to find those other angles. We have to find at least one of them so that we could find that fourth one, but we're not told directly any other measurements. But let's think about this. If we know that BCD is 242, then this arc right here, well, it would be 360. Oh, I'm still using a highlighter. 360 minus 242. So we know that this other arc here is 118. And if that's 118, this angle that's across from it has to be 1/2 of that, which means this angle is going to be 59. Now you have a couple of choices to find our last angle. To find this angle here, you may add those three and subtract it from 360, or you may take a look at this other arc and say, well, I can figure out that this arc here, I know that if we took 360 and we subtracted 184, I know that this arc on the other side would have to be 176. And if that's 176, then this angle over here has to be 88, right? It's 1/2 of the arc that's across from it. So no matter where our inscribed angles happen, whether that center of the circle is inside or outside or on the inscribed angle, the angle of the vertex is always 1/2 of that inscribed arc. Okay, let's take a look at one more example together. So this one, we know that CD right here, we are told is 25 degrees. And we also are told that DAE, that this angle is 45. And we want to find some other missing parts. So if I know that that angle is 45, well, then I know that this arc, this part of the arc, has to be 90, right? Our angle is always 1/2 of that arc. So we filled in an extra piece here. Now they're asking us to find this arc measure and also this angle here. So if we take a look at that arc measure, well, I know it's 90 plus 25, so this is going to be 115. And if I'm looking at this angle, I know it has to be 1/2 of 115. So that's going to be, let's see, 57.5. So using this property of the fact that your angle is 1/2 of the arc, we can find a lot of other pieces in these circles. Go ahead right now and in the chat, just send me a message and let me know that you are done.